Camps on everyone. Let's start off. Hope everyone has gone through the notes. For every class, you should resolve each and every question. Great. So last thing we did was this moment of inertia about the base. Let's go ahead with the question. Let's say this is your axis. This is your a triangular plate. Right angled isosceles plate. Mass M. This is the thing, and this is A. This is A. This is 90 degrees. Find the moment of inertia. Now you can't use it mh squared by 6, huh? That is derived for a when it's a base. This is something else. And what did you even do actually? You got it without integration? How do you choose an element like this? Then this thing looks like this formula, remember? A rod parallel to the axis. Case 2 or case 3, then MD square. You have seen before like that, then at least tell the right answer. Na? Don't guess wrong things like this. एग्जाम में क्या करोगे? MA square by 2. No, that's not right. नहीं हो just. Try. 30, 40 seconds more. Let's see. 4 MA square. That is huge, right? So when you take this right angle triangle, so this is the idea we're going to use. If you have a rod of mass m at a distance d, we know this thing moment of inertia is md square. So at a distance x from the top, take a thin rod whose width is dx. Now this angle is 45 because it's a bisector. That means this is also x. So now what you got is a thin rod whose length is 2x and whose width is dx. Then area will be length into breadth. Mass of this rod will be total mass of the plate by area of the plate is half base into height into 2x dx. That is 4m x dx by a square. This is the mass of that small rod. Now moment of inertia of this rod is md square. This will be mass of the rod into the distance x square. So I of the triangle will be integrate all these rods. Four m x dx by a square into x square. Limits will go from where to where? Remember, x is the perpendicular distance, so this was x is equal to 0. If you go straight here, this x will be a by root 2. It's not a, so be careful with the limit. It's a by root 2 because that is the height, isn't it? This is a, na? This is a cos 45. And then you're done. So integrate this. This will be 4m by a square. That would be x power 4 by 4, 0 to a by root 2. 4 will cancel. This will be ma square by 4. There, that's how we get this. Clear, everyone? Next one. Any doubts on this? How did we take the element, the mass, the rod? Next one. Let's say we have a square plate, x-axis, y-axis. This is your origin. So this square plate has a density sigma is equal to xy square. It is a weird density. So this is a comma 0, this is a comma a, this is 0 comma a. Means look at this thing. Suppose if x is equal to 1 and y is equal to 2, that will have some density. If x is equal to 2 and y is equal to 2, you'll have different density. So as you go to the right side, this plate is becoming denser and denser. You're getting the density depends on x and y coordinate. Sigma is the surface density. It's a plate. Actually, this is how we actually find moment of inertia for a rectangle, but this is even more dangerous one. So I want you to find the moment of inertia about the origin perpendicular to the axis. And I about origin perpendicular to the plane. You're getting what I'm asking? I about the corner. How will you do this? You have a plate whose density is changing both in x and both in y direction. The simpler version of this is finding moment of inertia of a rectangular plate. Meaning this is how the plate looks. The side view. Take a minute, I'll show you the technique. This is a variable density. And then what? It's split into triangles and do what? It's changing at every instant. Listen, let me show you this thing. We have to use something called double integration. First of all, how do you choose an element? So at a distance x from here, at a distance y from here, take a small rectangle whose width will be dx and whose height will be dy. I'm exaggerating the figure here. So this piece ka length is dx and this piece ka is dy. So what is the mass of this piece? Mass of this piece is dm is sigma into area. It's a rectangle. So length into breadth, dx into dy. But sigma is given as xy square. That means this piece ka mass is xy square dx dy. Where is your axis? Your axis is in this corner. Now tell me in the formula dm r square, what is r? Perpendicular distance, isn't it? This is your perpendicular distance r, which is root over x square plus y square. So the moment of inertia of this small piece will be dm, mass of that small piece into perpendicular distance. This will be xy square dx dy, and the distance is x square plus y square. This is the moment of inertia of that small piece. Now, when you want the moment of inertia, understand there are two variables here, dx and dy. There are two differentials. So moment of inertia of the plate will be double integral. So this is how we write. The meaning of this is you integrate it twice. It's a double integral of this moment of inertia, which would be x, keep all x together. So xy square dx dy x square plus y square. Now, how do you solve? Now, luckily, x and y are independent of each other. That means when you're integrating in x, y is constant. When you integrate in y, x is constant. You're getting it just like partial differentiation. There's no concept called partial integration. But the idea here is when x is changing, y doesn't vary here. So check out this carefully what we do. So what we do, let's push out the x outside first of all. X into dx, this guy comes out. Then we have y square, x square plus y power 4 dy. So y is stuck here. So remember when you're integrating with y, x is constant. When we integrate with y. And what are the limits? Y ka limits are going from 0 to a, x ka limits also go from 0 to a. I could have made a rectangle 0 to a and 0 to b. It doesn't matter. So now when I integrate this outside integral will be outside. Don't integrate this yet. First, you have to finish out the inner integral. Remember, x is constant, so this will turn out to be y cube by 3 into x square plus y power 5 by 5. Limits will go from 0 to a. This thing turns out to be integral x dx 0 to a. So you have to completely wipe out y from here. So put a ka value there. That would be a cube x square by 3 plus a power 5 by 5. Now integrate with x. Now this will be a cube by 3 x cube dx plus a power 5 by 5 x dx. This will go from 0 to a again, the next integration. You're getting how we integrated? First integrate with y, finish with y ka limits, then integrate with x. This is how we do double integration. Now if you integrate this, that would be x cube dx. How much is this? The x cube dx will be a cube by 3. I'll do one thing, wait. Let's make this a rectangle. A comma b and 0 comma b. So that you can clearly see like, what is happening. Then this limits will go from 0 to b. If everything looks like b only, you will feel like what? So now when you put the limits of b, x cube dx will be b power 4 by 4 plus a power 5 by 5 into b square by 2. That's your answer. Yeah, this is like double summation. Imagine in a computer program you write putting two for loops. So it's like a for loop going like, a, I, j. So first you keep j is equal to 1, then iterate I 1 to 10. Then put j is equal to 2 and iterate 1 to 10 and so on. I hope you know that thing. It's a double iteration or double summation. There. This is how we do for if you have something where it's changing with x and y. In case of a rectangular plate, your life is more easy. I'll turn the page. So if you take a rectangular plate and if you take about the center, we do the same idea here. At a distance x, at a distance y, we take a small piece here. So we will get dm will be mass by total thing m into lb. This will be your sigma into dx dy. This distance will be r. Exact same integration. So we will get di will be dm into x square plus y square. So you want moment to finish of the plate, double integral m by lb dx dy x square plus y square. This will be m by lb will come out. We will have dx outside, then we will have x square dy plus y square dy. Y ka limits will go from minus L by 2 to plus L by 2. X ka limits are reverse. Minus L by 2 to L by 2, B by 2 to minus B by 2. Because you're finding from the center. Because for a rectangle, you're taking this as origin. You're going this way. L by 2 comma 0 minus L by 2 comma 0. This is 0 comma B by 2 and minus B by 2. Integrate this. You end up with ml square by 12 plus mb square by 12. That's your standard result for a rectangle. But this is better. In a rectangle, the sigma is constant, m by lb. This is even more messed up. I hope everyone is getting how we are choosing the elements. There's also something called triple integral, dx, dy, dz. If you take three-dimensional bodies, then you'll have a triple integral. Generally, they won't go beyond this. Even double integral, right? This is mostly advanced questions. You can, be framed based on this. Means when they won't touch this kind of stuff. Any doubts on this thing? How did we choose an element? What is r square? And then when we are integrating, how are you integrating? So when you integrate with dy, x is constant. So by doing this, you have eliminated y from here. Now x will integrate one step at a time. If x and y are dependent on each other, then we are dead. Then you need to give me the relation between them. You have to prove it, Ojas. You can't say. If I take dy out, will the you can do the same thing, Ariman. Doesn't matter which one you integrate first. You want to integrate x first or y first, it doesn't matter. Try करके देखो ना वो just if you try to replace the two rods and see whether you get it. But both the rods will be non-uniform density, right? Those rods are not uniform. All clear with this? So this will be the rate for a rectangle about the center. I about the center. Perpendicular to plane. If you take L is equal to B, it becomes a square plate. Perpendicular to the plate passing through the center will be ml square by 6. In the end, we will put down all the results anyways. But this is how you do for plates. You take elements as dx dy. Clear? Devansh, Ahana, Arnav, Devika, clear? Next one. The next one is a hollow sphere. How do you find the moment of inertia of this? Mass m, radius r. You need to know how to integrate, because you know why? Exam they'll ask you like this. They will say this is a part of a sphere like this. And they will say find the moment of inertia of this. So if you don't know how to integrate, you will get stuck. You will just know the result for the full one. Mass m, radius r, so it's a part of a sphere. How do we do for the hollow sphere? If we can do this, that also will come. Both are same thing, only the limits will be different. Take a minute. Like I keep saying, the main important thing is how do you choose your elements? If you know how to choose your elements properly, that is half job done. The integration is actually easy. And this is not the first time you saw hollow sphere. I told you multiple times. The moment you see a sphere, you should know how to choose elements. I'm not expecting you will solve and get the integration. But if you don't even remember how to choose an element, that's a problem for us. This is how we choose elements, remember? I told you this in Centromas also. The most important thing is this part. If you got till here, you can handle every chapter. The moment you see a hollow sphere, you should know I should take element like this. You take small, thin rings. Remember? So, how do we do this? So, this is the sphere. So, from the center, at an angle theta, take a thin strip d theta. We get a ring like this. This width will be rd theta. This is how it looks when you open it up. This is the center. This is the radius. This is theta. So this is theta. So this will be r cos theta. That's your radius. Now, if I cut this ring, I will get a rectangle. This will be 2 pi r cos theta. That is your length, which is the circumference. This width will be rd theta. So this will become a rectangle. What is the area of the rectangle? Length into breadth. This will be 2 pi r square cos theta d theta. What is the mass of this small ring? Total mass by total surface area into area of this piece, which is m by 2 cos theta d theta. Now remember, this is a ring. What is the moment of inertia of a ring? Moment of inertia of a ring is mass of the ring into radius square. This is m by 2 cos theta. Radius is r cos theta ka square. So I of the hollow sphere is you have to integrate all the rings, which is mr square by 2 cos cube theta d theta. What are the limits? When you're at the center, theta is 0. When you go to the top, theta is 90. When you go to the bottom, theta is minus 90. You're going from minus 90 to plus 90. Please check the elements. So if you have got till here, now mathematically what to do after this, that's fine. That once max people actually teach you integration, it is a joke. But physics may you should figure out till this part. If you have figured out till this part, you're pretty good with these kind of problems. And when you're looking for advanced, these things are like bread and butter. Matlab socho advanced paper you'll find at least 30-40% paper will involve integrations. They won't give you something like silly stuff. They will expect you should know how to integrate. And this is not the first time. Again, I'm telling you, this will again repeat in fluid mechanics. This will again repeat in electrostatics, gravitation, magnetism. This will just keep popping up in modern physics. Wherever you see a hollow sphere, this is the idea. Any doubts on this page? Now, how to integrate the cos cube theta? Let me show you in the next page. We use a technique called integration by substitution. The limits are going from minus 90 to plus 90. So we write this thing as 1 minus sine square theta cos theta d theta minus 90 to plus 90. This is what we do. Put sine theta is equal to t. Then differentiate on both sides. Sine ka differential becomes cos theta d theta. This becomes dt. When theta is equal to 90, t is equal to 1. When theta is minus 90, sine minus 90, t is equal to minus 1. So this will transform into minus 1 to plus 1. Sine theta is t square and cos theta dt is t. It becomes a simple integration. dt minus t square dt ka integration. This is t minus t cube by 3. Limits will go from minus 1 to 1. This is 4 by 3. Check. Now, what is the difference in this question then? In this question, this will be integral mr square by 2 cos cube theta. The only difference here is your limits will start from here. Theta is this, and the highest point theta is 90. So limits will go from 0, some random angle theta, to 90. That is the only difference. If you just change the limits, you can get any weird shape there. There, once you got 4 by 3, I'll just substitute here. mr square by 2, 4 by 3, 2 by 3 mr square. This is the result for a hollow sphere. Have a look at this. Any doubts on the integration? How did I choose the element? Again, I'm telling you, today class gets over. Today or tomorrow maximum, you need to take a paper and resolve each and every question. If you don't do that, nothing will stay in your head. Everything will vaporize. Any doubts on this page? Clear, Pratik? Arush? Ojas? Arya? Ignajit? Surya? Arivan? Niharika? Clear? Devika? Got this? Next one. Solid sphere. These are some standard shapes, MR. How will you find for this? Try. I'll give you a minute or two. So first thing you need to ask yourself, how will you choose an element? You can take discs or you can take hollow shells, like an onion. Ever seen an onion? You'll find shell inside shell. That would be an easier one, but try. I'll give you 2 minutes. Think about it.
So could you show the last page? Yes, thanks.
Let's see. So this is what we do. You're getting, so this is what I was saying. In physics, now luckily, right, we have only like 6 or 7 shapes like this. As long as you know for every shape how to choose an element, it becomes quite easy later on for different chapters. Here we are finding moment of inertia. Last chapter we found the center of mass. Right? Then later on so on. So if you take a thickness dx, so the small volume, so this is the volume of the thin shell, is surface area into thickness. Surface area is 4 pi x square. It's a hollow shell into dx is the thickness. What is the mass of the shell? Total mass m by 4 by 3 pi r cube. It's a solid sphere, that is a mass per unit volume into dv. This would be 3m x square dx by r cube. Now, what is the moment of inertia of this hollow sphere? Just now we derived the result. 2 by 3 dm r square. R is x square here. So now you're saying I'm going to add all the moment of inertia of this all hollow spheres. So if I do that, I'm going to get a solid sphere. So I of the solid sphere, summation of moment of inertia of all these hollow spheres. That would be 2 by 3. How much is this? Let's simplify this. 2 by 3, 3mx square dx by r cube dx square. 3, 3 goes off. 2m x power 4 dx by r cube. 0 to r. That will be r power 5 by 5. 2mr square by 5. Check it out. That's your solid sphere. Check this out. Anyone not clear with the elements, please ask. Yeah. Next thing. Any doubts on this? So there. So that is how you can actually calculate, moment of inertia of different things with integration and stuff. But sometimes it becomes really complex. So we have two theorems which help us out. Now we don't have the derivations for this theorem. They're not needed because even in HSC it is only for parallax theorem it is there. So the first theorem is parallaxes theorem. So what this theorem says is, if you have a body, we have center of mass and we have a point A. If you have an axis passing through A, and if you have a parallel axis passing through center of mass, and the distance is d. So the moment of inertia about an axis A is moment of inertia about the center of mass plus total mass of the body into d square. Straightforward thing. Now here, few things you have to be careful. First thing, the axis passing through A and center of mass must be parallel. You can't take any two random axes. One. Second thing, d is the distance between the parallel axis. That's why it's called parallel axis theorem. Now, let me ask you something. Now listen to this statement, what I'm saying. Let's say in the class, the height of the student is given by height of the teacher plus distance between the student and the teacher. You get in the statement? The height of the student in the class is height of the teacher plus distance between the student and the teacher. Who is the shortest person in the class? Again, listen. The height of the student in the class is height of the teacher plus the distance between the student and the teacher. Okay, most of it did get it. Who? Teacher, na? Because the height of everyone in the class is teacher ka height plus something, isn't it? So the shortest person in the class is the teacher. So from that logic, if you see here, the moment of inertia of any system is moment of inertia about any axis is moment of inertia of center of mass plus something, isn't it? That means the moment of inertia about the center of mass is minimum. So among all the parallel axes, so if you draw a lot of parallel lines, the axis passing through center of mass has least moment of inertia. But first thing, all lines should be parallel. You can't compare perpendicular lines. Only parallel lines you can compare. The axis passing through center of mass has minimum moment of inertia. Next one, the locus of all the points with same moment of inertia is a circle. Think about it. If you take a body and if you look at the statement there, what it says, if this is the center of mass, so moment of inertia about an axis ICOM plus MD square, you didn't tell me which way. That means as long as I draw a circle with distance d, every point on this circle will have same moment of inertia, isn't it? So all these points will lie on a circle because the statement simply says ICOM plus MD square. D is the distance from the axis. So take a distance d ka circle. So all points on the circle are equidistant. So all these points have same moment of inertia. So the locus of all points with same MI is a circle where center of mass is the center. Are equidistant from center of mass. These last two things are direct questions in the exam. Clear with this? Let's see how they'll frame questions on this. So straightforward, IA is ICM plus MD square. Any doubts on this page? Let's see a question. Now, this theorem actually helps you a lot, saves you a lot from integration. Now we have a ring here, mass m, radius r. I want to find the moment of inertia about this axis, perpendicular to the ring and passing through the circumference. Axis perpendicular to plane and passing through circumference. Easy one. A rod of mass m length L. L by 4 from the center. Square plate, mass m, side A, passing through the corner. MR solid sphere, MR hollow sphere. Moment of inertia about this axis. Let's get them all. So the main thing, you should know the center of mass result. If you don't know your standard center of mass result, you're gone. Then there is no use of the theorem. Let's get them. Okay, try. I'll give you a minute. I'll show you. It's not tough. Just formula substitution. Let's see. So the idea is straightforward. Where is the center of mass here? So this is a line passing through the center of mass. This distance was r. So moment of inertia about A. Let's call this point A. I center of mass plus md square. This was easy. So this was I center of mass was mr square and the distance was mr square, 2mr square. बस इतना ही करना था. What about this thing? This is passing through the center of mass. So this is again IA is I center of mass is ml square by 12 plus m into L by 4 whole square. That would be how much? 7 ml square by 48. Easy. What about these two? Square plate. So when you are passing through the square plate, this is your center of mass. Remember, this is the perpendicular distance, which is half diagonal A by root 2. So I about the corner is ma square by 6. That is the moment of inertia about center of mass plus m into a by root 2 ka square. 2 by 3 ma square. What about this one? So the main idea is that you always take the distances from the center of mass. How to do this one? This can be split into two parts. Take the hollow sphere plus take the solid sphere. Find for both of them separately and then just add it up. So for the hollow sphere, about this line, now this is your center of mass, is 2 by 3 mr square. So this will be I1, which is 2 by 3 mr square plus mr square. For this is the center of mass. This will be I2. So this is 2 by 5 mr square. So basically you have to shift the axis to the common axis. There. Now you add it up. So I will be I1 plus I2. That would be mr square 5 by 3 plus 7 by 5. 46 mr square by 15. Is that clear, everyone? So just separate both the spheres, find for both of them about the tangent, and then just add them. That's what I said, Moment of inertia behaves like a scalar. You can just add it up about a given axis. Have a look at this. But in order to do this thing, you should know your standard formulas. If you don't know your standard result, this is gone. Any doubts on this? Next one. Any doubts on this? Next one. We have a body like this. This is your center of mass. This was A. This was B. This distance is D, and let's say this distance is 2D. Moment of inertia I about B is given by 15 md square. Find IA. We have an half ring, mass m and radius r. It is hinged at the top. So this is an axis into the plane. Find the moment of inertia about A. Be careful. Parallax theorem says we always have to go from center of mass. You cannot jump from anywhere to anywhere. You can't jump from B to A directly. It is always from center of mass. Try. A and B both are related. Get them both. I'll give you 3 minutes. Hmm, 7 md square. Let's see. First was easy. Hmm. What about the second one? I'm more interested in that. First is fine. First, I just gave it like a starter for the second one. Perfect, Rogers. You went and jumped into the trap. It's like you go to a restaurant, right? And the person tells you, it's a don't order paneer today. And you say, okay. And then you order paneer butter masala. Yeah, you to God hai. You know, this is a trap, right? You came like this, you went there and you jumped into a river somewhere here. So trap देखा भी नहीं तूने. How the hell did you even get MR square, Ray? Hans did get something weird. MR square plus MR square pi minus 2 by pi whole. And it is bad, Ray, Ansh, but इतना भी खराब नहीं है. Check your calculations. You cooked up somewhere. Or maybe you did get it, I guess. Can you just expand that a bit? Expand करके कर. But फिर भी pi square आ रहा है तुझे. That is weird. Let's see the first one, everyone. So the first one, right, is this. You can't use the formula directly. So IA is I center of mass plus MD square. IB is I center of mass plus M into distance between center of mass and B. That is 3D ka whole square. You cannot write between A and B directly. So now subtract them. Then we get IA. IB is given 15 MD square. I center of mass will cancel. This is minus 8 MD square. So we get IA is equal to 7 MD square. How are both the questions related? Now in this question, what most of you did, this was the center O. Now you tell me, what is IO? IO is MR square, agreed? Why? Every point is equidistant. But is O the center of mass? Where is the center of mass of half ring? Center of mass of the half ring is 2R by pi. You cannot shift from O to A directly. That's what I said. Both the problems are similar. Only the numbers are bad here. So how do we do this thing? So moment of inertia about IA is I center of mass plus M into R minus 2R by pi whole square. I about O is again I center of mass plus M into 2R by pi whole square. I don't want I center of mass, I'll subtract it. This is IA minus MR square. This thing can be written as A square minus B square. That would be M into, if you add them, you'll get R. If you subtract them, you will get R minus 4R by pi. If you shift it that side, you will get 2MR square, 1 minus 2 by pi. Check. Please check if you got the same thing, then it is fine. Pretty good one. Remember this B part is again come in oscillations. Any doubts on this? Next one. Next one. Any doubts on this? So be careful. The parallax theorem you can't use from anywhere. You always have to shift from center of mass. We have a square frame here. Square frame, not a square plate. Four identical rods. Mass M, length L. So they're rotating about this axis of rotation. This angle is 45. Find moment of inertia. You're getting how this is rotating? It's like this. That square frame is rotating about the vertical axis. Meaning after some time, this is going to become like this. I hope you're able to visualize the picture. So axis is in the plane and this thing is rotating about. Find the moment of inertia of this square frame. It's not a square plate. Get this? Any answers? Seven ml square by 12. Okay, we have two answers. Four baja, we have 30 seconds more. Anyone else got it? 9 by 2. 7 by 12. I hope you guys didn't take the square plate. 9 by 2. No, that's not the answer. No, Daksha, that's not the answer. Let's see. That looks right, Ahana. Aryaman, that looks right. Let's see. So how do we do this thing? So first of all, if you remember, we have done this result before. If you have a rod of M and L, and if this was axis, and this was 45, what is the moment of inertia? ML square by 3 sine square 45. Remember this? That was the second case or third, fourth case, I guess. So now what I'm suggesting, directly finding from there is a mess. It's difficult. So instead of that, I will try to find about the center first. Why? There's the center of mass here. This angle is 45, this angle is 45, this is 45, this is 45. So I about the center of mass will be ml square by 3 sine square 45 into 4. Now parallel to this, we have this axis. This perpendicular distance will be L by root 2 half diagonal. Therefore, IA is I center of mass plus, remember, this is the total mass of the system into d square. Sine square 45 is 1 by 2, so that is 2 by 3 ml square plus mass is 4m L square by 2. That is 8 ml square by 3. That's how we can do this. The problem, see, if you try to do from this directly, we have an issue there. When you try to do about this, chalo, this you can calculate ml square by 3 sine square 45. This you will calculate. The problem is, how will you calculate this piece? You have to find this center of mass and then you have to shift this distance. You cannot shift from this corner because that is not the center of mass of that one single rod. Are you getting it? Be very clear. Using parallax theorem, be very attentive about that. You cannot shift from anywhere you want. But when I take all 4 of them, luckily my center of mass is passing through the center. I can take for all 4 of them. You can't do this for a single rod. So I will find the moment of inertia about the center of mass for the full frame and then I'll shift it. Check. Easy? Make sense? Any doubts on this? How did you guys get 7 ml square by 12? Right? What did you guys do? Did you do that only? Yeah? You shifted it from this corner for each rod. You used the wrong formula only. You took plate. मैं starting से कितना बार बोल रहा था? It is not a plate. It is not a plate करके. I told almost 3-4 times. Why do you think I was shouting non-stop? Next one. I hope everyone got this. So just clear, na? Surya. Next one. The moment of inertia I is given by 3x square minus 2x plus 7. X is some variable. This is the moment of inertia as function of x. Find I about center of mass. There's no other information. Shape, mass, nothing is given. Only this much you know. Right, watches. No, Purvaja. 28. How do you guys get 28? It is wrong. Let's see. Now, what is the idea here? The idea is, remember, we made a statement, the moment of inertia is minimum about the center of mass. So indirectly, I'm asking you to find the minimum value of this function. Moment of inertia about the center of mass is minimum. Therefore, I center of mass is I minimum. How do you find minimum? Maximum minimum. First differential, di by dx. 6x minus 2 equal to 0. You can check with a double differential, d square I by dx square, 6 greater than 0. So therefore, at x is equal to 1 by 3, we do get minimum. So substitute there. Therefore, I center of mass will be 3 into 1 by 3 square minus 2 into 1 by 3 plus 7, 20 by 3. Easy? Next one. Next thing, the next theorem is your perpendicular axis theorem. Now again, the word says, yeah, it should be 1 by 3. Perpendicular axis theorem. Now look at this word itself will tell you everything. If I know moment of inertia about an axis, and if you want about a parallel line, use parallel axis theorem. If I know moment of inertia about an axis, and if you want a perpendicular line, use perpendicular axis theorem. Make sense? So you always need to ask yourself, what do I know and what is being asked? If these two lines are parallel, use parallel axis theorem. If these two lines are perpendicular, use perpendicular axis theorem. Sometimes we have to use both of them. We will see. Perpendicular axis theorem. So unlike parallel axis theorem, this thing has a limitation. This is only valid for sheets. Valid for planar bodies. You can't use this for 3D objects and stuff. Like triangular sheets, square plates, rectangles, like that. So what this theorem says is, if you have a sheet, this is your x-axis, this is your y-axis. This is your z-axis. So the theorem says Iz is equal to Ix plus Iy. Better way of writing is this. Iz is the moment of inertia about an axis perpendicular to the plane. Whereas Iy, Ix and Iy are axes parallel to the plane, in the plane. That is the thing. You cannot take any axis as whatever you want. Ix plus Iy must be in the plane. Iz must be perpendicular to the plane. So the statement goes like this. The moment of inertia about an axis perpendicular to the plane is equal to the sum of the moment of inertia of the two axes in the plane. Yeah, and all three axes must pass through the same point. All axes must intersect and must be mutually perpendicular. Hmm. Okay, let's see some examples how to use this. Now, this perpendicular axis theorem is useful to find for sheets, but there is a condition. If the sheets don't have symmetry, this is useless. I'll show you what it means. Let's say, example, let's say we have a disk. You want to find the moment of inertia about the diameter, right? So this is what we do. Now, if I take one more line here, y. Now for the disk, we already know moment of inertia about the perpendicular axis z. Now, if you see the top view, this is how it would look. Axis, axis, this is x, this is y. Can you see here clearly? Ix and Iy both are equal because of symmetry. So now if you write the theorem, Iz is equal to Ix plus Iy, Iz is mr square by 2, which we have proved by integration. This will be 2 times Ix. Ix is equal to mr square by 4. There. So the moment of inertia for a disk about the diameter is mr square by 4. About an axis perpendicular to the plane is mr square by 2. Now same thing, same question. Suppose if this had been a triangular plate, let's say this is the centroid. Let's say I naught is given, okay? Let I naught be equal to I. We will calculate that later on, but let's say it is given. Now, if I try to use the theorem, look at the problem here. The theorem is not wrong. The theorem will still is valid. The theorem says Iz is Ix plus Iy, great, but Ix is not equal to Iy, we can't solve. Are you getting the problem with this? So whenever you use parallel perpendicular axis theorem, the theorem is valid. For a sheet, Iz is Ix plus Iy. But if Ix and Iy are not symmetrical, you can't solve the problem. Or at least you should know one of the values Ix and Iy. So perpendicular axis theorem is pretty useful when there is a symmetry. Without symmetry, the theorem is valid, but it is not useful. So be careful. Not being valid and not being useful are two different statements. So a disk is symmetrical, Ix and Iy. A triangle is not symmetrical. Let's see a question. Yeah, the theme is that. So if you know about an axis and you want in the parallel to the axis, use parallel axis theorem. If you want about an axis perpendicular to the given axis or known axis, use perpendicular axis theorem. Next one. Next one. So we got a disk. There. This is your diameter. So this is an axis tangential and in the plane. Find I. Take a minute. I'll show you. We have two different answers. Let's see. Now, let me show you two things. Tell me which one is right. First one, I'm going to do like this. This is the perpendicular axis. This and this. So this is X, this is Y, this is Z. So first I'm going to use perpendicular axis theorem. Then I'm going to use parallax theorem. So from this we get Iz will be Ix plus Iy. Mr square by 2 is 2 times Iy. Iy is Mr square by 4. Then I know this Mr square by 4. And we want to find about this axis, about A. This distance was R. So Ia will be Mr square by 4 plus Mr square. This was 5 Mr square by 4. Perfect. Second time, what I will do this time, I will use parallel axis first. Then I will use perpendicular axis. I know about this axis, Mr square by 2. I'll find about this axis. This would be 3 Mr square by 2. Now I will use Iz is Ix plus Iy. So this is 3 Mr square by 2, 2 times Iy. Iy is 3 Mr square by 4. What's the problem? What's the problem? Right, Ahana, right, Puruja. What do you guys think, others? What's the problem? There is no symmetry here. The statement is right. 3 Mr square by 2 is Ix plus Iy. Ix is not equal to Iy. I can't solve. So be careful. That's what I'm saying. If you're going to use perpendicular axis theorem, ask yourself, is there a symmetry between X and Y? If there is no symmetry, do you know the value of X or Y? You don't know the values of one of them. There is no symmetry. You can't solve. So we use this guy, 5 Mr square by 4. Clear, everyone? Ask me if you're confused. Take a break. Come back by 7 2. Any doubt so far? Okay, come back in 10 minutes. Yeah. Comes on everyone. Next thing. Let's say we have a square plate. And passing through the center, if you have an axis like this. Axis in the plane and passing through the center. This is making some angle theta. So it would kind of look like this. If you look at my screen now, see, this is your square plate. Catch here, catch here. You're getting it where I'm catching? And then rotate. You're getting it? See, you can catch in the diagonals, right? This is the one axis, diagonals. So this thing, right, is not in the center. It is like you're catching here somewhere and you're catching here somewhere, and the line is passing to the center. You're rotating like this. If you see my screen, you can see this thing. This is what I was saying. You're catching somewhere like this and rotating it. Making sense? It's at an angle theta. Mass of the square plate is m and a. Find the moment of inertia. Meaning, if you look at the side view, it would kind of look like this. Like this. This would be the perpendicular. Same thing if you have a square plate, but this time the axis is from the corner and it makes 15 degrees. Find the moment of inertia. Let's get them both. Okay. Right, Purusha. Get the next one also. It is in the plane. Axis is in the plane. Green is perpendicular, I got. Why do you need that green? Chalo, chhod do. When your obsession with green one. Find about the red one, right? The axis is in the plane. Let's see. Now, if you see, square is special. You can't do this with the rectangle. Look at this. Suppose if you draw a line randomly like this through the center, can you clearly see this piece and this piece are equal? Symmetrical. See, if you observe, maybe I didn't draw it up to the scale. This is big, this is big, this is small, this is small. Can you see? They're symmetrical. That means if I draw one more line passing through the center, you will notice this piece and this piece are also symmetrical, isn't it? That means if I draw two perpendicular lines, Ix is equal to Iy. Symmetry is there. This happens for a square. Means if you take a square plate and as long as you pass through the center, you cut however you want, you will get equal pieces. And then we know from the perpendicular axis theorem, Iz is equal to Ix plus Iy. And Iz we have already calculated, which is ma square by 6. This is 2 times Ix. We get Ix is equal to ma square by 12. The best thing about this is independent of theta. You pass the axis through the center at any angle, it doesn't matter, answer remains same. That means if you have a square plate, if you send it through the center like this, I1, if you send a diagonal like this, I2, or if you go like this, I3, you go like this, I4, doesn't matter, all are equal. Be careful, doesn't work for rectangle, only for a square plate. Clear? That's because any two perpendicular lines will be symmetrical. Now, can you do the B part? No, that's not the answer. Now you have a line in the plane passing from the corner at an angle 15 degrees. Now what? नहीं फरोजा, you can solve it. इतना complex नहीं आएगा. Think, I'll give you a minute. I'll just tell you one thing. Just because, there are two parallel lines, the diagonal is not the perpendicular distance. You need to understand D is the perpendicular distance between parallel lines. Any distance between 2 points doesn't become a perpendicular distance. Try to understand the meaning of that. Think, I'll give you a minute. It's main about the perpendicular distance. Let's see. So since you want to find about this axis, which is 15 degrees, you also need to draw a line parallel to this line and passing through the center of mass. This is the center of mass. Right? This is also 15 degrees. Now the common mistake what people do is this. This is not the perpendicular distance. You have to drop a perpendicular from here. Isn't it? That would be the perpendicular distance. This will be a by root 2. And this angle is 45. You can clearly see that angle is 60 degrees. So if I take this point A, B, and C, so BC is the perpendicular, this angle becomes 60 degrees. That's the reason giving that 15. 15 plus 45 becomes 60. And this is a by root 2. This will be the perpendicular distance D, which is a by root 2 sine 60. Think logically. if you take these two lines, what is the perpendicular distance? A by 2, no? So when you rotate these lines, when the angle becomes 45, then the diagonal becomes the perpendicular distance. Are you getting it? For 45 degrees, then the diagonal is the perpendicular. I hope that is making sense. This was 15. Yeah, you're done. So how much is this? Root 3 a by 2 root 2. That is your perpendicular distance. Now apply parallaxis theorem. So I about a is I center of mass, which is ma square by 12, which we just proved, by m into root 3 a by 2 root 2 ka square. Take out ma square common, you will end up with 1 by 12 plus 3 by 8. Take out 4 also common. Then you get 1 by 4 by 3 by 3 plus 3 by 2. 1 by 3 plus 3 by 2, 3, 9, 11. Ma square by removed 4, 24. Check. Is this making sense, everyone? So the most common mistake is that a by root 2 is not the perpendicular distance. A by root 2 will be a perpendicular distance if the angle had been 45 degrees. Any doubts on this? Clear? Next one. Next one. We have an half disk. Mass m radius r. We have an axis passing through the center, making angle theta in the plane. Find the moment of inertia. This is the axis. We have a solid hemisphere, half of it. Mass m radius r, solid hemisphere. Get them. How do we do this? Right, Purva. Try. Right, Anna. Let's see. It looks weird, but it is actually, if you see, there's a symmetry. This is one thing, from the beginning I was saying, as long as you keep the mass distribution same, it doesn't matter what kind of shape you make it. So what I will do, see these kind of questions now, the best thing to do is what? Stretch it. This thing, stretch this half disk into a full disk. Some people do like this, they will say we will add one more disk of another half disk, make it a full disk. In that case, what happens now? There's a good chance I have seen people messing up with the maska values. You'll get an errors. So Keep it simple. Stretch half disk into a full disk. When you stretch it, what will happen? Thickness will become half, right? But anyway, thickness doesn't matter. Now see how it looks. So basically you made it into an half. Now you might think like, okay, but they both don't look similar. That is fine. Just look at this thing. So what you did was, if this point was A, this point was A. If this point was B, this point was B. Can you look at this thing? This piece and this piece are identical. Did the mass distribution change? So by making it into a full disk, right, I didn't change the mass distance. So we observe the perpendicular distances remain same. That means an half disk is as good as a full disk of mass. This is m by 2, this is m by 2. Therefore, so this one is as good as a full disk about a diameter. You can just treat like this. So I will be mr square by 4, independent of theta. I can use the same logic here. I'm going to construct another hemisphere like this, mass m by 2, mass m by 2. So what you got is a full sphere. Now again, same logic. If I take this point is A, this point is A, did the distance change? The perpendicular distance did not change. So this one is as good as having a full sphere M and R, and you want about this axis. So this was 2 by 5 mr square. Use parallaxis theorem. 2 by 5 mr square plus mr square. So this can be used when you're sure by stretching it or making it into a full shape, the answer doesn't change. Can I do for this? Can I stretch this into full? Again, see, if you stretch this into full, this point, you're making this point, right? Distances are changed, right? Are you getting it? If you make this into a full sphere, there is a problem. But in semi-sphere, to use parallaxis theorem, yeah. Where am I? So this is the center of mass, right, for full sphere. I made the half hemisphere into full sphere, right? Chalo, you want to say that फिर भी चलो ना, for hemisphere center mass कहाँ पे होगा? It will be on this line only ना रे, 3r/8. It doesn't matter. But is this logic clear, everyone? You can't do for this model. You can't do this thing. So always be careful. If you want to say I'm going to stretch it into a full shape, you have to make sure the distances don't change. Is that clear, everyone? Next one. But how to do this thing? If I ask you this question, how to do this? Isn't this question same as offering? You will find the center of mass. You know about this axis, then we have to use parallaxis theorem and solve. The question would look quite similar to that offering wala question. There's no way to directly do it. Next one. This is a solid sphere with a cavity. Density is rho, radius is r. Remember, it's a solid sphere with cavity. Technically speaking, you can't see the cavity, it is inside. We have done something like this in moment, center of mass. I told you. Whenever you have cavities, what to do? Find this. Do you guys remember the technique for a cavity? What we do? We take the full, we remove that, and we get it. That is the idea. Give it a try. 2-3 minutes. Simplify karna behan. You and your laziness. Exam में you'll write that only and come क्या? 31/80. Nee, Adi. That's not the answer. Ariman, that's not the answer. Ansh, seriously? 0.3 mr square. Where did you even get that? Mr square by 20. Why are you guys getting such beautiful answers? Let's see. Again, remember when you're subtracting, you are supposed to subtract the moon to finish about the same axis. So take the full sphere. Minus, take this small sphere. Then you get this one. Maybe the mistake you guys are doing, you're subtracting about a different axis. I want about this axis. So I'm supposed to find about this axis. Are you getting it? About the tangent. This axis. This is what you need to find. So this mass will be m, which is rho into 4/3 pi r cube. So this mass will be m and r. This mass will be rho into 4/3 pi r/2 whole cube. So this is actually m/8. So this is a sphere of m/8 comma r/2. 387/980. Wow. Now what? What is the answer for this? Let's call this thing I1, which is 2/5 mr square. Let's call this thing I2. What is I2? Remember, you have to use parallaxes theorem. That will be 2/5 small m small r square plus m into r square, which is 7/5 mr square, where small m is m/8 and small r is r/2. Are you getting this? Then your final answer is I1 minus I2. 2/5 mr square minus, how much is this? 7 mr square by 160. Calculate this. Just give it a try. That is 57 by 160. You're right. Check. Clear, everyone? So maybe the mistake you guys are doing, maybe you're subtracting this one, I guess. You should find moment of inertia for all the systems about the same axis and then subtract. This is how you do cavities. Same thing we did, center of mass similar logic. Clear, everyone? Next one. We have an equilateral triangular plate. So we have an axis. O is the centroid. Axis perpendicular to the plate and passing through centroid. Mass of the plate is m and side is a. Find I. How do we approach this? There is a way to do this without any integration and all that stuff. I think I'll give a minute or two. We use something called symmetries. MA square by 25. 20 MA square by 4. Okay. That's not the answer, but I'm interested. How did you get that? Listen, 5 MA square by 24. No. Now, before that, let's say if you have linear objects, the moment of inertia I is proportional to the mass and the length square. But we know for linear objects, the mass is also proportional to L. So this will be proportional to L cube. What is the meaning of this? Suppose if I have a rod of length L, and if you take a rod of length 2L, you find moment of inertia about any axis. If you say this is I, this will be 8I. You're getting it? So the moment of inertia is proportional to the L cube for rods. Now, if you take for planar objects or sheets, like sheets, triangles, square plate, again, I is proportional to m into L square, but mass of the sheet is proportional to the side square. So this is L power 4. That means if you take a triangle and if you take a bigger triangle whose side is 2a and this side is a, if I say this is I, this will be 16i about the same axis. Similarly, if you take 3D objects, I is proportional to ml square, mass is proportional to L cube. It can be a cube or a sphere or something. So this is actually L power 5. Means if you take a small sphere of radius r and a big sphere of radius 2r, if this moment of inertia is I, this is 32i. Is this clear, everyone? So m into r square, that m will depend on the type of the object. Now, using this, let's say this triangular plate which we have, about O, let the value IO be equal to I. We don't know that. We need to find that I. Now, this side is A. So now what I'm suggesting, let's take a bigger one of 2A about the same centroid O. Now for the bigger one, what is I? This I bigger plate will be 16 times I. Do you agree? Just now we saw, no? For a plate, it will be 16 times L power 4. Now, interestingly, for an equilateral triangle, when you take this big one, and if you cut it into 4 pieces, you'll get 4 equilateral triangles. Yes? Where this O is the common centroid, this one is the centroid of the one triangle, this centroid, and this centroid. So now the moment of inertia of this full triangle is nothing but moment of inertia of this first triangle, moment of inertia of this middle triangle, moment of inertia of this triangle, and moment of inertia of this triangle about the same axis. Means I need to find moment of inertia of all these three about this axis. Make sense? Now in an equilateral triangle, what is this height? This height will be a by 2 root 3. This height also will be a by 2 root 3. That means if you look at these distances, these are a by root 3. So the moment of inertia of the first triangle about O will be I, which I don't know, plus parallaxes theorem md square, which is I plus m into a by root 3 ka square. So I of this big plate will be I1 plus I2 plus I3. All three are equal about O plus IO because O is about the same thing. So this is 3 times I plus MA square by 3 plus I, but this is equal to 16I. So this will be 12I is equal to MA square. I is equal to MA square by 12. Makes sense? Think about what we did. I started with the story that the small triangle be I. The big triangle is 16I. The big triangle can be split into 4 triangles. So for the 4 triangles, about the respective centroids is I not only. But I have to use parallaxes theorem to shift them to the central centroid, isn't it? So if I use parallaxes theorem, that will become M I, the moment of inertia of each triangle, plus this distance square, which is MD square. So from here to here, that was D. Into 3 because there are 3 triangles. So 3 outer triangles plus the central triangle should give you the big triangle. This is another way of doing, one is integrations, one is parallaxes theorem, perpendicular theorem. This is symmetries. Please have a look at this. Sure. Anyone confused with anything here? Can we do problem perpendicular axis theorem? Abhi hai na? Do you know about these two? You should know Ix, Iy, right, Puroja? We don't know both of them. फिर भी you can still calculate Iy. If you take Iy, you can use this as one triangle, this one triangle, use that formula mh square by 6. But इसके लिए क्या करोगे? X के लिए you can do that also. You can figure it out by using parallax theorem about the base and all that. हाँ, but it is possible to do that way, but it becomes quite long. Try करके देखो, you should get the same thing. Is this clear, everyone? Next thing, radius of gyration. Now this is not exactly a concept. This is more of a practical thing, for the lab purpose. For example, let's say tomorrow you're going into a lab and doing an experiment. I won't expect that you will remember moment of inertia for all the values, isn't it? Think about it. Let's say you're manufacturing devices for an experiment. I won't expect the consumer or the person who's doing the experiment will remember solid cylinder ka formula, hollow shell ka formula, and all these things. So what I tell them is, we will tell them, boss, see, there's something called radius of gyration. So this is what the manufacturer will do. So the distance at which total mass must be located to get same moment of inertia as a system. So let's say when the manufacturer is manufacturing a disk, he has made a disk m into r. Now I won't expect you to remember the formula mr square by 2. So what we will do, we will replace all this with a particle m and let the distance be k. Then we will say moment of inertia of the disk is mr square by 2. If this bit had been a particle, the moment of inertia is mk square. We will say k is r by root 2. This is the radius of gyration of the disk. So next time when you go to the lab and you see this disk, what will be there? On the disk, someone will print this. M is 100 grams, K ka value is 10 centimeter. So how to find the moment of inertia then? So I of the system is M into K square. So I don't need to remember what is the shape. Is that making sense? So moment of inertia is simply mk square. So while manufacturing, right, the manufacturer will take that value, he will measure the k ka value for you and he will type that on the device. So all you need to do is when you go to the lab, you should know moment of inertia is m into k square. Just multiply and you're done. I don't care what is the shape, what is this thing in anything. Suppose if you are manufacturing hollow shells, then the manufacturer will do this thing. 2 by 3 mr square is equal to mk square. So on the shell, it will be printed. The radius of gyration is 2 by 3 into r. So that value will be given directly, 10 centimeter or something. All you need to do is just multiply m into k square. Is this making sense? So radius of gyration is simply if all this mass had been a single point at a distance k, if it had the same moment of inertia, then what was the value of k? This is more of a convenience for the person who's doing the experiment, because we won't expect him to remember all the results. All that he needs to do is just do m into k square. So the k ka value will take care of the actual formula. The manufacturer will know what is the formula. So he will find the value of k and he will print on it. Got this, everyone? So in that question, if someone gives you radius of gyration, mk square, that's it. I don't care what is the shape. So they will say like this, for a cylinder, the radius of gyration is 10 centimeter, mass is 50 grams. I don't even care what is the shape. I'll do mk square. Clear? Then now let's put on all the results together at one place. It'll be easy for you to revise. So if I take rod, so if you have a uniform rod passing through the center, this is ml square by 12. You need to mug up these results. ml square by 3. ml square by 12 sine square theta. ml square by 3 sine square theta. md square. Then we have arc, ring, hollow cylinder. So this is the axis. This is the axis. This is the axis. So moment of inertia will be mr square, assuming all have same mass. Then we have sector. Then we have disk. Then we have solid cylinder. So the side view will look like this. Pizza ka slice. I is mr square by 2. Then we have the same thing, disk about the diameter. Even better, even if you take half disk about an angle. Again, for the same mass, m and r, both should have same mass and r. Then I about the diameter is always mr square by 4. Then we have our square plate. Let's say if you have rectangle, about an axis perpendicular to the plane, ml square by 12 plus mb square by 12. Again, axis perpendicular to the plane, ma square by 6. About a line passing through the center at any angle, ma square by 12. This is axis in plane. And then hollow sphere, solid sphere, this one is important, scalene triangular plate. Just let's triangular plate. So about the diameter, the center, 2 by 3 mr square, 2 by 5 mr square. About the base, if you take this height to be h and mass m, mh square by 6. This is a very important result, useful. Now, there is one more shape. If you have a cylinder, mass m, radius r, and length l, and if you take about this axis, this can be treated as a rod plus a disk. Means you can compress this like a rod of m and l, and you can compress this like a disk mr. So about the center of the rod, you will get ml square by 12. About the diameter of the disk, you get mr square by 4. If I combine this would be ml square by 12 plus mr square by 4, perpendicular to the axis. You're getting how is the shape? It's like if you take a water bottle, this is the axis. It's going perpendicular to the middle of this thing it is going. It is a thick water bottle. Quite an important result. It was asked multiple times. This was an axis perpendicular to the axis of the cylinder. You can try integrating and find out, but that is the easiest way. If you can compress the rod, it looks like a rod, and vertical direction it is like a disc. And then we have some non-standard shapes also. These are not standard results, but can be derived. Hollow cone. Solid cone. Equilateral triangular plate. So if you're passing through the center, hollow cone, interestingly, the answer is mr square by 2. It looks like a disc. Solid cone is 3 by 10 mr square. How to get them? You have to integrate. So basically here the elements will be thin rings. You can take a ring and eliminate. For a solid cylinder, the elements are thin disks. This though we just now proved about the centroid. Ma square by 12. This is perpendicular to the plane. Other than this, we have again some unorthodox ones. This generally shouldn't be asked, but sometimes I saw, in your classes exam, they just put it. Suppose if this is an axis perpendicular to the plane, and let's say we have an axis like this. This is axis out of the plane, making an angle theta. This is not in the plane. This is mr square by 2, 1 plus cos square theta. The derivation is not important. Exam, it won't, mostly they won't ask you this also. Just in case, because the result looks fine. If it's a disk, it's a ring. Again, axis out of the plane. This guy was mr square by 4, 1 plus cos square theta. And then we have one more weird one. Suppose if this was the axis, and if you have a triangular sheet like this, so what this theorem says is, replace this triangle with 3 point masses. of m by 3 at the center of the sides. Like this. So here m by 3, this is m by 3. Any triangle, it can be scalene triangle also. This is the midpoints. And then this theorem says if this distance was r1, this distance was r2, and this distance was r3. The moment of inertia of this triangle or this plate is m by 3 r1 square plus r2 square plus r3 square. This last three results, right? These two and this thing, they're not there in the portion. They're almost like gone case, but just in case, have an idea. There, that is about all the moment of inertias. Now we know how to calculate torques and we know how to calculate moment of inertia. So next class, when we catch up, we're going to see how to do no slipping condition. That would be the third part in this. That won't take much of our time. I think that should take around 40-45 minutes. And then we will start off things moving now. So the actual things will start in the next class. Okay, so make sure to go through this. We have already done 29 questions. So, and we are just starting the chapter now. The basics are done. So go through this stuff, right? And then resolve. So, okay, with that, we'll wrap up for the day. So I'll see you guys again on Tuesday at 5:40. So any doubts, anything you can stay back and ask, also free to leave. So take care, stay safe.